In this video, I will try to help you develop your intuition for knowing how to draw shapes written in cylindrical and spherical coordinates. Okay, so for instance, take this question. So imagine you are asked to sketch the following surface, and this surface is written clearly in cylindrical coordinates because we have rho, phi, and z, which are the three numbers in cylindrical coordinates. And the equation for this surface is rho equals z, phi is a variable that goes between 0 and 2 pi, and z is a variable that goes between 0 and 1 over square root of 2. Okay? To refresh your memory, this is what cylindrical coordinates look like. So we are in the xy plane here, and we select a point in 3D space here, and the value of z is simply the z coordinate, as usual. Then the value of rho is this distance here, is the distance between the point and the z-axis, which can also be described as the distance here, yeah, which is the projection of your point into the xy plane. So when you project this distance here, yeah, is the distance in the xy plane, and then phi is the angle in the xy plane between the x-axis and the projection. Okay, so now sketch the surface given by this. So I would like to have a disclaimer before I do this, and it's the fact that I could spend hours trying to teach you different examples of different surfaces in cylindrical and spherical coordinates, and probably it wouldn't help because it really depends on you. It's your progress on this topic will depend on you scratching your heads, thinking about this, substituting values of rho, phi, and z that fulfill the equations, and try to figure out what this shape is. Only by practicing you will get good at it. Okay, so in this example I'm just going to show you how I could think about it, but it's not useful unless you think for it yourself before I show you the answer. Okay, but let's have a think. So here we clearly have two variables that are changing. Okay, so phi is changing between 0 and 2 pi, which means that this angle here is changing between being somewhere along in this plane, which corresponds to phi equals 0, and then we are moving that all around 360 degrees up to 2 pi. Okay, so whatever this surface represents, it must have a symmetry of revolution against around the z-axis. Okay, now we see that z changes between z equals 0 and z equals 1 over square root of 2. So this means that whatever our surface is, it must be contained between two planes. The bottom plane would be z equals 0, which is this xy plane here. Yeah, that is z equals 0. And then it will be contained between that plane and another plane, which is higher up here, that will be z equals 1 over square root of 2. So our surface is contained between these two planes. But of course, the key information for the shape of this surface is rho equals z. So how can we figure out what this looks like? So what I would recommend is this trick. So imagine that we fix phi to a given number between 0 and 2 pi. So remember, these two variables, phi and z, are going to be our sliders. Yeah. So we are able to select any value between the limits, and by moving those two sliders simultaneously, we will cover all of the points in this surface. Okay, but let's say we fix phi to a certain value of the slider. Okay, so let's say that phi is fixed to this fixed value here. So now consider this plane, this tilted plane here. So this tilted plane, we could now draw it in 2 dimensions, right? So we could draw this tilted plane, so the vertical axis would be z, but the horizontal axis now the horizontal axis would be like this axis here, right? And what is that axis? That could be called the rho axis, because we are moving in the direction of increasing rho. Okay, so we could plot z versus rho such that this plane here is simply the plane that I drew here. Okay, fine. So now, knowing this, we can say, okay, what does the equation rho equals z look like in this plane? Well, rho equals z is the equation of a straight line. And z is changing between 0 and 1 over square root of 2. So we have z equals 0 here, and we have z equals 1 over square root of 2 here. So that will be our maximum value of z. Rho is equal to z. Therefore, the slope of this line is simply 1, right? So we could say that this angle is 45 degrees, or pi over 4 radians, okay? So this means that in this plane here, we should be able to draw this line at a pi over 4 angle, and that will be for a fixed phi in a single position. But we can change phi between 0 and 2 pi. So what will happen? That our line in this plane, it will perform a revolution around the z-axis, okay? So the surface that this produces is a cone with the tip at the origin, right? As I said, there's not much I can explain. This is pure intuition. You need to get used to this. So if we get this z equals rho line and we do a revolution around the z-axis, we are going to get this cone, okay? Therefore, the surface that this is representing would be a cone that looks like this. It's the surface of this cone, the curved surface of this cone, okay? So we would have, like, if I'm drawing a mesh here, it would be something like this. So the surface of this cone is given by these equations here. What is the height of this cone? The height of this cone is 1 over square root of 2, because that's the limits in z, okay? So now picture this. Imagine we are at some point in the cone here. What happens if we move the slider for phi? So if we change phi between 0 and 2 pi, then we will move around the cone, but on the same z plane. So we will move around this circle, right? Because z is kept constant, but we are changing phi. So we are moving around the circle. Now imagine that we keep phi constant, but we move the slider z, okay? So this means that phi is constant, so we are always on the same, we are always like in this plane, yeah, with a fixed phi, and we are moving z. But by moving z, when we move the z slider, we will also be moving rho, because rho equals z. So therefore, we will be moving up and down this side of the cone like this. So by varying the slider of z, we are moving around the cone in this direction, and by varying the slider of phi, we are moving in this direction. So this means that using the two sliders, we can arrive at any point on the surface of the cone. Yeah, we can just select the appropriate z and then change phi to go with anywhere in the cone. Okay, so this is just one example. You have many more examples in the notes, and I encourage you to go through the notes and practice. So check out problem 3, 3a and 3b. Also check out problem 2a and 2b. And finally, at the end, there is a problem 6 and problem 7. These are all examples of different surfaces written in spherical or cylindrical coordinates. And be aware that during the live session, I will actually do a poll everywhere poll asking you this question. So this is rho equals z is the one we just did. Yeah, I will ask you to see if you remember that. I will also do this one, which you have the same options, A, B, C, and D, but I changed the equation. So now we are in spherical coordinates, and this is theta equals pi over 4, okay? While phi changes between 0 and 2 pi, and r changes between 0 and 1. So please think about it. You have a reminder of spherical coordinates here, and in the live session, I will ask this to you, so be prepared to answer. So think about it. What does this shape represent? And finally, I will also ask you about this. So instead of giving you the equation and asking you for the shape, I'm going to do the opposite. I'm going to give you this shape, which is this curve here that looks like a spring, okay? And this spring is rotating around the z-axis, but it has a period, which means that it completes a full revolution, and when z increases by an amount a. Okay, so this is this distance here. And what I am asking is, can you write the equation that it corresponds to in cylindrical coordinates? So please think about it, use your intuition, or if not, start substituting values, maybe for z and for phi. So you start substituting and see what happens, okay? And please answer me in the live session. And just practice this, because it's a very important skill, having the intuition to write down equations in spherical and cylindrical coordinates describing different curves and different surfaces. Okay? Thank you very much. See you in the next video.